Hello everybody, this is the third video of the video series about feature engineering techniques. In the previous videos, I explained the feature engineering pipeline, machine learning pipeline, feature engineering pipeline. After the introduction part, I explained feature improvement and the feature construction techniques. So today we will focus on feature selection. I will explain the difference between the feature selection and other techniques, and of course I will show a couple of examples. So let's focus on feature selection part. If you are interested in feature improvement and feature construction, of course you can watch the previous videos. And now let's focus on feature selection. So definition of feature selection is simple. You will have n features, and all of the features are not always helpful for the model. And we know that when you have more features, you will have more dimensions. And if you have more dimensions, that means you will have expensive computational costs during the training and also in the inference time. So feature selection is selecting the best subsets from your feature set to increase the performance of the model. And here you can see we have n features at the beginning, and after the feature selection part, you will have key features. So key features should be less than n features. That means you will decrease the cost while increasing the model's performance. But how can we do that, and when should we do that? So first of all, if you are in this field, in the machine learning field, probably you heard that curse of dimensionality. So when you have too many features, too many dimensions, this is bad in terms of computational cost, and also it can cause overfitting problems. And we know that dependency can be a problem among the features, and of course all of them will affect the speed of the training. And the main objective is just remove useless and non-contributing features, but use optimal, contributing and useful features to decrease the cost and increase the classification or regression metrics. We have some libraries, feature engine and scikit-learn. Scikit-learn may be the most popular library. We have feature selection part in scikit-learn. Also, we have other libraries, other APIs. You can search them. For example, feature engine. I added these two links here. You can inspect and read more about them. Now I will show a few examples. So I am using a data set, and in this data set we have some features like this: house age, rooms, bedrooms, population, latitude, longitude information. So this is about the price of the houses in the California. So I used this scikit-learn dataset fetch California housing. So I'm using the same data, and after loading the data, you can reach the data, features and targets, etc. So here I'm using data target attribute to create Y, and then I can use df3, this data frame, to create my X, because they are all features. I don't have target column here. Okay, now I can use train test split method from scikit-learn. I already imported. So I'm giving the X and Y. The test size is 0.2. That means 20% of the data will be test data, 80% will be training data, and the random state just to control the randomness. And let's check the shape. So here we have more than 16,000 data in our training set and more than 4,000 data in the test set. And we have 10 features, 10 columns in the X, and we have 1 column in the Y. So here you can see we have some features, and actually these are our original features, and I added this after regulation and the region columns, these features, after the feature construction process. So we used the age information to create the after regulation. Also we used the latitude and longitude for the region information. So you can watch the previous video for the feature construction part, but we know that these are not the original features, and we will see that if these are the really helpful features or the original ones are better in terms of model. There are different techniques. First of all, let's use removing features with low variance. So under the scikit-learn feature selection part, you can import different techniques. For example, variance threshold. The idea is simple. you can check the variance. So you can apply some statistical techniques to understand the impact and the power of the features in the prediction part. So we can set a threshold and we can say that if the variance is below than this threshold, so 0.8, then don't use these features. And to do that, after importing variance threshold, you should instantiate this variance threshold, specify the threshold value, then this selector will be fitted by training data. Let's do that. And we created this X-train with low variance, and we can check the shape. Here you can see instead of 10 columns, we have now 7 columns. So here you can see these average bedrooms, regulation, and region features, they are removed. Here you can see the latitude and the longitude, they are here. Okay. And of course you should be careful after removing the features, after applying this feature selection, you should also update your test data. Okay. Because the dimensions should be same, the size should be same. Also, directly you can see the name of the features with the feature names in and features and feature in attributes, but they are available in the new versions. Okay, if you are using the scikit-learn older versions, you cannot see these attributes. Another approach we can apply, you can use feature importance attribute of the random forest, so tree-based models. For example, random forest regressor, we are importing from scikit-learn ensemble, and then we are instantiating a random forest regressor. Here, regressor, the number of estimators and the random state, these are just the hyperparameters for the random forest model. I will not go to the details of this part, but we instantiated a simple random forest regressor model. Then you can train this model with fit method, and then after the training part, we have a feature importance attribute, and then you can see the importance of features. So let me run. Okay, now we can see the column names and the feature importance. I will use the zip and then I will sort them and I will create a dictionary. So just let me show the output. Yeah, as you see here, the feature name will be our key and the value will be the feature importance value. And they are all sorted because I sorted them. So the most important features in this data set is this income, and then second one is the occupation, and then latitude and longitude and the age. So based on these feature importance values. So simply you can say that based on this information, this region after regulation, they are nearly zero. So I don't want to use them because I want to reduce the dimensions. Also the population and the average bedrooms, they are not contributing too much. You can also decide to use the other features. So let's calculate the regression matrix. So this is a regression problem. We are trying to predict the house prices, and I just run this. Let me run also this one. You can see I'm using predict with test data, then this predicted values, and the metrics from scikit-learn. So like mean absolute error, mean squared error, R2 score. These are the common regression metrics in scikit-learn. I think you are all familiar with these metrics, and they need actual value, y-test, and the predicted value. So we created predicted value here, and then we obtained these absolute error, squared error, R2 scores, and you can see the scores here. Then we will apply feature selection, and after the feature selection part, we will generate the same scores, and we will compare if the difference is significant, too much or not. So now let's just use the first 4 important features. So based on this information, the most important features are this med inc, average occupation, latitude, longitude, these features. I'm using only these ones, so extreme with feature selection, and you can see the columns. I'm just using them, and based on these columns, again I will create a test, so they should have the same dimensions, same column names, right? And I can repeat the same process. I can create a regressor with the same hyperparameters. Then I can fit the model with this new data set after the feature selection part. Okay, training is completed and it is shorter than the previous one. And here you can see Now these are my regression scores. I just repeated the same part, created predicted values and these regression metrics. And if you look at the mean absolute error, I have 0.31 and here I have 0.31. So even better, right? Because this is smaller than the previous one, so even better than the previous one. And the mean squared error 0.24, 24, nearly same. So as you see, I just selected 4 features instead of using 10 features, but I have nearly same performance scores. So I reduced my cost, and this is a simple example of feature selection. Now I want to provide the overall of feature selection methods. So the feature selection part can be considered under the dimensional tree reduction. So basically we are reducing our dimensions with feature selection, and the objective is increasing the performance and reducing the cost. So under the feature selection, we have some unsupervised learning techniques and also some hybrid techniques and some others. So we have a lot of methods and there is no best for all problems. But the most common ones are filter, wrapper, and embedded techniques. So I will try to explain briefly these techniques, but as I said, there is no one best solution for all. There are some advantages and disadvantages for each, and you should find your feature selection according to your problem and the data set and your priority. So first of all, the filters, these are model agnostic techniques. That means we are not using any model, any classifier, any regressor, but we will use some statistical techniques like variance, we did it, or chi-square. There are other techniques, but the idea is, since this is model agnostic, this is faster, cheaper in terms of computational cost, and the model evaluation part will be at the end. So there are a lot of techniques under the filter category. You can apply them if your priority is the cost and if you want to obtain the best features faster. But from my experience, I can say that wrapper methods are more successful, but they are expensive in terms of computational cost. Therefore, if the speed of this process is not important, is not the most important priority for you, you can check also wrapper methods. So here they are adding and removing some features and then evaluating the models iteratively until the model is good enough. That means there is an iterative process. It's a bit expensive in terms of computational cost because you are training different models in each iteration you are training models. But with these techniques you can have very good results. And for example, we have sequential feature selection, recursive feature elimination, recursive feature selection, or we have also some heuristic based feature selection. For example, you can use genetic algorithm, you can use different optimization algorithms because at the end this is an optimization problem and you can have a very good results. So embedded methods, embedded feature selection techniques, they actually integrated this process, feature selection process, into the classifier level. But this solution is between the filter and wrapper methods. For example, you can check XGBoost algorithm. Actually, it has this embedded feature selection inside the model. This is faster than wrapper, but still we cannot say that this is always better than wrapper or filter. Okay, that's all. You can check some papers. I shared also the links here and in the description of the video. You can check these papers and you can have better depth understanding about feature selection. Okay, now with this video we completed the first 3 techniques: feature improvement, construction and selection. In the next video I will explain the feature extraction techniques, another important and common technique. Then we will cover feature learning, and I hope this video series will be helpful to clarify what is feature engineering, what is feature construction, selection, extraction, and I hope you will not confuse about these terms. So thank you for the watching.